we developed a computer tool named ADBox, which stands for Adjacent Box Beam Bridge Analysis and Rating. So you can see the logo of ADBox on the right top corner of the screen. So this tool is specialized for the load rating of precast prestressed adjacent box beam bridges. So we developed it using Visual Basic of applications and is included in a user-friendly MS Excel spreadsheet. So this tool is developed in MS Excel spreadsheet to reduce the cost and time required for learning sophisticated software. So ADBox is automated with approximately 3,000 lines of VBA coding. So this is the flowchart we adopted for the development of ADBox. So the orange chart in the flow represents the input parameters such as bridge information, material properties, box beam section properties, load rating settings. If the box beam section properties are from the Ohio standards PSBD 0207, we can directly use it from the drop-down menu in the ADBox. So if it is custom sections, we can give the manual dimensions like the older sections having multi-cell configurations. We can use it, we can input it, the dimension of those sections manually. So after inputting these parameters, ADBox calculations includes live load distribution factors, maximum movement and shear due to dead loads and live loads, movement and shear capacities of the beam, and finally the calculation of load rating factors. So for the custom sections, it can also calculate the section properties automatically. So after calculating these calculations automatically, ADBox displays the final load rating factor results as a rating factor value, which are grouped based on the load cases. So let's look into the capabilities of ADBox. So ADBox can handle rigorous calculations automatically. The calculations include dead loads and live loads, live load distribution factors, so calculation of bending moment and shear forces, calculation of nominal moment and shear capacities, and finally the calculation of final load rating factor values. The dead loads include the input from the bridge information. Live load includes the 15 vehicle types required by Ohio Department of Transportation Bridge Design Manual. So these vehicle types include design vehicle, Ohio legal vehicles, permit vehicles, emergency vehicles, specialized hauling vehicles, and AASHTO legal vehicles. So ADBox has also capability to load rate custom vehicles with up to 35 axles. The moment distribution and shear distribution factors are calculated based on the distribution factor method. So during the calculation of the distribution factor, we need to compute the torsional constant. So for the single cell box beam, torsional constant is calculated using Saint-Venant equation, whereas for the multi-cell box beam, we applied the shear flow framework for torsional analysis. So the detailed process of these calculations can be viewed on the project report. So ADBox calculate bending moments at the exact location of the maximum movement rather than at the 1/10 of the span method. So we can see on the figure, so when we move the design truck HL93 along the span of the beam, red circle indicates the exact maximum movement location, and black circle represents the center. So we can see that the exact maximum movement location has the maximum movement value compared to at the center, which indicates that the exact maximum movement location method calculates more accurate value than 1/10 of the span method. So ADBox is developed to calculate the maximum movement at the exact location of maximum movement. So typical shear check point is located at a distance equal to effective shear depth, that is dB away from the face of the bearing of the support. We can see that on the figure on the left, the distance dB away from the support. So additional shear check is also performed where the shear reinforcement and spacing changes. So we can see the additional shear check locations on the bottom left figure. So this is the point where typical shear check location is performed, and this is the point in the beginning of region 2 where the additional shear check location is done. So ADBox is developed to calculate shear force at both typical and additional shear check location. So ADBox calculate nominal moment capacity using the rectangular stress block method, whereas it calculates the shear capacity using the modified compression field theory. So the detailed procedure of these methods are found in the project report section 3.1.3.5. So finally, ADBox calculates the final load rating factors using limit state for 3 distinct procedures. So the procedures are design load rating, legal load rating, and permit load rating. So legal load rating is performed using strength 1 limit state. An additional check is done for inventory loading using service 3 limit state. And legal load rating is performed using strength 1 limit state. And finally, permit load rating is performed using strength 2 limit state, and optional load rating is also done using service 1 limit state for permit vehicles. So these load rating are performed using load and resistance factor rating method for strength limit state, and allowable stress rating methods for service limit state.